Hey, my name is Oscar Spencer, and I'm a co-author of the Grain programming language. My talk today is Grain, your WebAssembly first programming language. So for topics I want to talk about today, first, what even is Grain? Then we'll go through some features and examples of the language. We'll talk a little bit about what we've been up to in the past year and even in the past few months. We'll talk about our roadmap for things that we're planning on working on in the next few months. And we'll talk about ways that you can get involved. So first, what is Grain? Grain is a programming language made exclusively for WebAssembly. So we have no other compile targets. Our only focus is WebAssembly and trying to be the best language for WebAssembly that we can. So the first step is it's strongly typed. So we believe that, hey, now languages today, we have amazing type checkers. Let's take advantage of them and make sure that we're not getting runtime type errors. We're functional programming oriented. I say oriented because yes, we take a lot of ideas from functional programming, but at the same time, we understand we can't always be purely functional, and we have some ways to do other types of programming in Grain as well. We have modern day language features. We care about things like pattern matching that are all the rage today. And of course, we work with all of your favorite WASM runtimes, including WASMTime, Wasmer, Node.js, and the browser. So what's our design philosophy? We have a big focus on developer experience. So what that means to us is, yeah, we took the type checker from OCaml because we've seen, hey, we can get the best developer experience in terms of finding errors and refactoring our code using the OCaml type checker. So we brought that in. We want to be functional but flexible. So that means taking features like let mute from Rust. So that way we can actually do mutations in our functional language. And we want to make sure we give developers the tools they need to move fast. So we want to have a standard library that's just as good as Ruby's or Python's. So for technologies, the compiler is written in ReasonML, and our WASM code is emitted via binarian. The great thing about that is that means we have access to the full suite of optimizations that binarian provides, so we can generate lean and mean WebAssembly modules. So how did the project get started? It was actually in early April 2017. In fact, just a few days ago, Grain had its 4th birthday. And at the time, all the WebAssembly languages that existed were really geared towards low-level and systems programming and making sure that critical paths of your application could be really, really fast. In fact, I remember that the premier language at the time was C. And that's really cool and that's awesome, but we saw a unique opportunity where we could build a language that was very high level to get more and more folks using WebAssembly. So we decided to go for it. And we said, hey, let's pull together our favorite pieces from all the amazing languages that we've used. And if you want to know a little bit more about the name Grain, join me for cocktails after the summit. So let's go through some features and examples. So first, the very basics. We use the let keyword to bind values to names. And bindings in Grain are immutable by default, like any reasonable functional programming language. So here we're binding numbers, Boolean strings, etc. Like I said before, we took let mute from Rust. So if we want to have a mutable binding in Grain, we use let mute to say, hey, this binding is mutable, and the compiler will give us an error if we ever try to mutate a value that's not mutable. Tuples are a fantastic way to bundle pieces of data together, and we've got those, especially if you have a function that tends to return multiple pieces of data. Tuple is a great way to take care of that. And just like other Grain data types, we can destructure them. So here on line 1, we create a tuple with a user's name and age, and on the second line, we destructure that into the value's name and age. Functions are the bread and butter of any programming language, and we use arrow notation for them. Grain is an expression-based language, meaning that the result of any expression is what the function returns. So if you look at the second example here, we have a block that this function is returning. But notice that on line 4, we don't use a return statement. Because it's the last statement, it gets returned. We've got recursive functions, and we can create those with the rec keyword. So if we want to avoid mistakes by not accidentally calling a function recursively, Grain takes care of that by making sure, hey, you need to use the rec keyword. So in this example here, I want you to note that we have an if statement here. And sort of in the same pattern, we don't use a return statement. On lines 3 and 5, those values are at the end of the if expression, and the value of the if expression itself is returned from the function. All functions in Grain are first class, meaning we can pass them as values to other functions. In a functional programming language, this is pretty important because we're going to be doing a lot of mapping, a lot of reducing. So we want to be able to pass functions to other functions and let them do processing. So in this example, we're importing the list standard library, and we're just mapping a simple function that adds 1 to the values of a list. In this case, 0, 1, 2, getting the result 1, 2, and 3. Function closures. Now, this is a pretty exciting thing. It seems like something that's pretty basic, but actually is really important. It allows a function to access its local state and keep track of it no matter where it's passed around. So here we have a make counter function. Here we have some local state where it keeps a counter. And then the value that we're returning from this function is another function where it just increments the local count and it prints it out. So if you look on line 9, we make a brand new counter. And then every time we call it, it's mutating that internal state so that the counter is incremented and we print out those values. Data types. So enums in Grain are a fantastic way to model data that has multiple variations. Enums are crazy powerful. They're not just simple values that you're just going to pass around like constants. Enums can be constructed and can contain other values to become way more powerful. When you combine them with pattern matching, they make you feel like you have superpowers. So here, we're using them just like any other Grain value. In this case, we've got some pizza toppings, in this case, cheese, pepperoni, and peppers in the list. And we have a function that computes the price of a single topping. In this case, we're just comparing, hey, is this topping pepperoni? If so, it's $1.25. Otherwise, everything costs 50 cents. Then we've got a reducer function, which simply takes a total and adds the current price to it. And then on line 10, we reduce that over the base price of a pizza, $4. Now, this is great, but pattern matching makes this way more powerful. So here we have a pattern match, our first pattern match. And so here, when you get a topping, the Grain compiler can take a look at that and switch to the right case for you. Now, this is a pretty simple example, but as we look at more complex things, you'll start to see some of the power. One of the beauties of pattern matching is that it forces you to handle all possible cases. So in this case, we have a program where we're getting the price of a topping, and we handle cheese, we handle pepperoni and pineapple, but when we compile that program, we get a compiler warning that says, hey, you didn't handle all the cases. And more importantly, here's an example of a case that you missed. In this case, it's peppers. So enum variants can also contain values. They don't have to just be static. So if you take a look at our menu item enum here, for like items on our menu, we have pizzas, calzones, salads, cannolis, and pizzas and calzones can have toppings. So we declare it to say, hey, a pizza can have a list of toppings and so can a calzone. So when we declare a pizza here, we have a pizza and we just pass it a list of toppings. So now when we do pattern matching, we can pattern match on these more complex structures. So here we have a pizza with a single topping of cheese, and we can print out a custom message for whenever we see just that case. Then here on line 3, we see, hey, we want to match on pizzas that have any toppings, and we use an underscore in Grain to denote an any match where we match everything. And then for salads, we can print out a custom message, and then for anything else, we can print out something else. We also have records. They're a little bit similar to tuples, but each field has a name, and properties are accessed via dot notation. So here, we declare a record for a customer. They have a name, they have an email, and they have an order, which is just a list of menu items. So on line 6, we declare a customer, and we actually give it its name and email and order. And then on line 11, we use that dot notation to pull values out. Of course, what would be pattern matching if we couldn't do bindings with them? So if you look at line 4, we are checking out a calzone and seeing what toppings it has, and we can pass that value out to other functions, in this case, checking specials. If we've got certain specials for certain toppings, we can print, hey, we have certain deals for those things. Otherwise, we can say we have no deals for you. And of course, we have a catch-all at the end to make sure we handle all of our cases. So of course, records can also be matched. And so on line 8 here, the important thing to see is we have these record fields, name and order, which are from that original record definition. And bindings are created for these so we can print out the order for the customer and we can print out their order. You saw a little bit of a sneak preview. One of the things that we did there was we printed out the customer's order. That's not a common feature to my knowledge in many functional programming languages. In Grain, you can print out any value. For me, that was always one of my gripes with functional languages was I had to define a custom printer or I had to have some preprocessor that would define custom printers for my types. But in Grain, you can print any value, debug, and move on with your day. If you don't need that behavior in production code, you can disable it with a compiler flag, but it's incredibly useful for simple debugging. So as you've seen so far, we haven't really used any type annotations because the compiler is able to determine all of our types based on just how we use the values. So we typically save annotations for when we feel that it makes the code cleaner, but in this case, we're just adding the values X and Y so the compiler is able to tell that those things are numbers. So these number annotations are not necessary, but if we feel that they're useful, we can add them in. And of course, the type errors are the real cream of the crop here, pun intended. So the type checker is going to make sure that all of our types line up. And this reduces bugs immensely. So in this example here, we say let 5 equal the string 5, and we try to add them together. The type checker is going to let us know, hey, this thing's a string, but we really expected that thing to be a number. And I can go back and look at the code and say, hey, oh, I messed that up. This should actually be a number. One of my favorite statistics around compilers that have type checkers like this is when Facebook's Messenger.com switched from JavaScript to ReasonML, and they went from 10 bug reports a day down to 10 bug reports a year. And that's just the power of a modern day programming language that can handle and check for these errors before you ship it out to your customers or your clients. So for me, like, this is something that's pretty awesome. Of course, we want to have a robust standard library. We have a whole host of libraries here. Of course, some of my favorites are the list standard library, the option standard library, result. These are fantastic libraries that are really at the core of what Grain is all about. But of course, we're continuing to develop them and develop them even more. But I want to call out specifically the sys libraries. So these libraries provide access to the WebAssembly system interface, are better known as WASI. So if you've ever used WASI just directly, you'll know that you typically have to allocate some memory, pass those values into the functions, they'll write things, you'll pull them back out. We've already done all of that in our standard library and our sys libraries. So in this particular example, we have a program that accesses the arguments to the program. When we compile this program and run it with Wasmtime and pass some arguments, you see we get an array with the program name and the command line arguments. Here's a little example, and this is from Advent of Code 2020. And this is a very simple problem. The gist of it is you have a list of numbers and you want to find what two numbers in the list when added together equal 2020, and then print out the value that is those two numbers multiplied together. I am not endorsing this code. I'm not saying, hey, this is the most efficient way to write this code. But this gives you a really good idea of what we're aiming for with Grain and the level of high-level programming that we're trying to do. Of course, we could write this code where we have a nested for loop, where we just iterate over the list twice and check all the numbers against each other. But in this particular example, we use the list standard library to do a product of the list with itself. And list.product will create a brand new list with tuples of the two arguments of every single thing in those lists combined together. So here we create a product, and then you can see on line 10, we just do a simple find function, and we say, hey, find the value in the list, or the tuple in the list where the two values added together are 2020. And also notice that we are doing a tuple destructure here as well. Now, again, this is not the most efficient code, but being able to sort of write the one-liner or in a situation where you're actually going to have sets of data and you want to do a product or things like that, this is sort of how high level we're trying to think. We're not trying to think in terms of pointers or anything like that. We're really focused on the high level programming concepts. Of course, working with foreign functions is incredibly important. There's a lot of times where a host environment is going to want to provide some function. We're going to want to call that function. In Grain, we can do that via the for and wasm syntax. So in this particular example here on lines 3 and 4, we import some for and wasm functions, in this case, get token and set token. And get token doesn't take any values, but it does return a wasm i64. And set token takes a wasm i64 and returns void. Of course, we do have to convert those wasm values to Grain values. And so we're using the conversion library here. But we can grab that token, get a Grain int64, and then we can do stuff with that token. We can do math on it. We can do whatever sort of processing we want. We can get a brand new token, and then we can call that function and by converting back to a raw wasm value. So of course, we're going to make this a lot better, and I'll talk a little bit about that more when we get to the section on the roadmap. So what have we been up to? We've been speeding up. So I actually gave a talk to a local meetup virtually about a year ago. And I had a slide in that slide deck where I said, hey, we've been doing really, really well. In fact, in the past year, we've gotten 53 PRs merged. Well, as of today, in the main Grain repository, we have 273 PRs merged in the past year. And I think that's a testament to the amount of work that we've been willing to put in and the amount of work that our contributors have been willing to put in to make this project a true success. So I've been really excited to see this happen. We've been working on Grain binaries. So of course, previously, like the only way to really use Grain was to build the compiler on your machine. And we want to make sure that Grain is very accessible for anyone to use the language. So now you can get access to Grain just by going to the website and following the instructions. Additionally, we have a JavaScript version of the compiler, which is available for platforms that we don't yet support. So if you have some machine in some platform that isn't particularly common, you'll be able to use the JavaScript client. And particularly, we should, in the future, be able to compile Grain programs in the browser, which is incredibly exciting. In fact, that project was spearheaded by core team member Blaine, who, in fact, took more than a year, I believe, just getting that working. So definitely hats off to him. Static linking. This is sort of my baby project that I had been working on for the past 2 months or so. And this was something that was largely asked for by community members in our Discord. So up until now, Grain modules were separately compiled and they were dynamically linked at runtime. And that was largely because when we first started Grain, we thought, hey, the major use case for WebAssembly was just going to be in the browser using JavaScript. But the WebAssembly landscape evolved, and we saw that folks were really excited about using WebAssembly in way more places than ever before. So over the past 2 months, I worked on getting a static linker built for Grain so we could continue to do our separate compilation, but then link all modules together before you run it on whatever platform. And now you can. And this was a whole bunch of work. It required a rewrite of the entire Grain runtime. And we had some runtime support that was in JavaScript. We had some runtime support that was in AssemblyScript, which was really amazing. And hats off to the AssemblyScript team for helping us through all of that. It was absolutely amazing. But we had to get it all written in Grain for this to work. So it was a massive undertaking. But this was something that happened because of folks in the Discord who were asking, hey, I want to run this on Cloudflare. I want to run this on Fastly. I want to do all these things. So this was a pretty exciting thing. Also, inline compiler flags. We had some folks who wanted to use Grain to do work with smart contracts. And one of the things for them is they said, hey, you know, my program is pretty short-lived. I don't need garbage collection. I just wanted to move fast. And one of the best ways to do that is to add this flag, no-gc, which would disable garbage collection. And additionally, with the inline compiler flags, we could then just put that at the top of the file. And now that flag will only apply to that particular file. So this was particularly exciting for folks, you know, doing that, and we can see this being more useful in the future as well. So where's Grain today? Well, we just released version 0.3, which is incredibly exciting and includes a lot of the things that I've talked about here. That might sound like a particularly small number, but in the programming language landscape, that's actually pretty huge if you see the rate at which minor versions come out. And there's far more to do. We're rapidly approaching version 1.0, and we've completed most of our production-ready objectives. In that same talk I was talking about earlier, I had a slide that said, hey, here's everything we need to do to be production-ready, and we've more or less completed all of them, which is incredibly exciting. So we can see things picking up and things gearing up. So what's on our roadmap? Better FFI support. So currently, if you want to work with foreign functions, you do have to have some knowledge of how grain data is represented in memory, but we want to remove that barrier to have everyone be able to work with the host environment and whatnot instead of just library authors. We'll add some abstract types to Grain for working with more host references, so that'll make things a lot nicer when working with JavaScript and things like that. And we'll have an even better JavaScript API for the folks who are working with Grain in the browser. Static linking with assembly script. When I wrote the linker, at the end of the day, I realized, hey, actually, I believe this could be extended to work with not just Grain programs, but all sorts of programs. So whether it's Rust or AssemblyScript, we believe we could actually statically link those together. If you're a WebAssembly nerd like me, you've probably been following some issues, and there's been an issue open on Binarian, I believe, for a long time of implementing a WASM link functionality. And I believe a lot of the work that I did here, potentially we could upstream into making WASM link actually real. The big thing there is how do memories work together? How do tables work together? But as the WASM GC proposal lands, it'll be a lot easier for languages that utilize the WASM GC to work together harmoniously. So I'm pretty excited for this, especially to take advantage of some of those sweet libraries that are already written in AssemblyScript. And of course, long grain. This would add the ability to run Grain in 64-bit mode. And by the way, this is probably the project that I am most proud of for coming up with an amazing name for. But the idea of adding memory 64 to Grain is having programs that want to use way more memory able to do so. Because right now, 32-bit programs can only use 4 gigs of memory. So this is pretty exciting to see the applications that we can unlock by doing so. And it opens the door for way more optimizations for us. A lot of the 32-bit values that we've been using so far can fit into a 64-bit word, and we can add some metadata in there as well to maybe stack allocate things that we were allocating on the heap before. So this is a pretty exciting project that I'm personally really excited for. And of course, the infamous DOM standard library. Back in the day, we actually did have a DOM API, and it was one of the first proof of concepts for Grain. In fact, co-author Philip and I, on I guess the first day that Grain was really born, I remember the feeling when we got our first Grain Lambda attached to a DOM event, and it was incredibly exciting, and that's really what energized us to work on the language. And it was pretty darn cool, but the hard thing was garbage collection, because we'd be collecting all these JavaScript references and have to manage them in the JavaScript runtime, and it's actually a little bit difficult. But now we have WebAssembly reference types, and so this really puts the DOM standard library back on the table. And I think it'll be even cooler when I talk about something a little bit later, which is now macros. So we want to implement these user-defined macros for common tasks that are expanded at compile time. So they're really useful for things that are arduous, like, for example, in a functional language, defining a JSON object is a little bit annoying. It's what you see on the right. But we want to make macros work a little bit like tagged template literals in JavaScript. In this case, having just JSON, being able to write just the string JSON, but have that expanded at compile time, so that way there's no performance loss at runtime for having these macros, and making them super easy to define. So how can you get involved? Discord. Please join the conversation. You can get your questions answered, you can give feedback, you can advocate for all the features that you want implemented. Largely, like I said before, like static linking, the inline compiler flags, even binaries to a certain extent were things that folks were asking about in the Discord. So definitely join in and you can influence the work that we get done. And our community meetings happen on Discord as well. So if you want to say hi, you want to listen in, definitely join, and you can influence our entire roadmap and throw up everything that we've been working on. And you can join that at discord.gg/grain-lang. You can also contribute. One of the easiest ways to contribute is through GitHub issues. If you believe that you found a bug when you're writing a Grain program, open an issue and we'll take a look at it. Languages are pretty big and encompassing, and so don't think that we necessarily know that the bug exists. Definitely just let us know, open an issue, and you've contributed just like that. And of course, suggest new features or request new features. Our work is just driven by what people are asking for, so you'll be able to help shape the roadmap. Another awesome way to contribute is via documentation. So whether it's the docs that are on the website or the contributor docs, there's a lot that we have to keep up to date. And one of the beautiful things about working on documentation is that you'll learn a ton more because you'll have to explain concepts to others. So you'll have to know the concept yourself really, really well. So this is an amazing way to get involved. We have a ton of tooling. Besides the main compiler, we have Binarian ML, which is OCaml, our ReasonML bindings to Binarian. We have the entire website. We have our language server. So if you want to make the auto completion in Grain much better, that's an amazing project to work on as well. And these are things that happen because of contributors. In fact, the language server was pretty much written single-handedly by one of our contributors, Marcus, who decided to take it on because he wanted to have those hover types in his editor. So these are things that any language needs to have that can readily be worked on. And of course, contributing to the standard library is an amazing way to actually write Grain code, but also write code that folks are going to be using forever. And in a lot of ways, standard libraries help define the language itself, and it makes contributions incredibly impactful. And like I said, you can write Grain code, and what's better than that? And of course, you can contribute to the main compiler. There's lots of different areas of the compiler that you can work on. And it's not like anyone on the core team was an absolutely amazing compiler expert before getting started. In fact, co-creator Philip and I, when we first started, had only written a toy compiler at that point. But we're more than excited to help anyone who wants to learn while working on the compiler. And if you think I'm friendly, you get to work with me, and I think that's a pretty big bonus. And of course, you can definitely sponsor us. We're a small team, we have day jobs, we have other responsibilities. Ultimately, Grain is a passion project for us. We do it because we love it, we do it because we love WebAssembly, and we want to see that high-level language exist for WebAssembly. So if you like what we're doing, consider sponsoring us. If you're a corporation, we definitely have capacity for different projects to get done. So it's definitely something to consider. So thank you. You can find out more about Grain at grain-lang.org. Join our Discord, discord.gg/grain-lang, on Twitter at grain_lang, and you can find me on Twitter at Oscar_spin. And that's about it.